Bismillahirrahmanirrahim. Welcome to the second part of 17th lecture of Statistics and Probability Theory. We will continue with the topic uniform distribution. In previous part we have discussed discrete uniform distribution. Now in this part we were going to study continuous uniform distribution. So let's suppose that we have a random variable x, and this x is a continuous random variable. In previous part this was discrete random variable. Now in this case this is continuous random variable. So whenever we have discrete random variable, we will have the discrete probability distribution, or you can say it probability mass function. And whenever we have continuous random variable, we will have probability density function for it. So now I want to construct the probability density function for this particular random variable. Let's suppose that this is y-axis, and this y-axis is representing the probability density for each possible value of the random variable, and this x-axis is the axis for the random variable x. So let me restrict my random variable that as this is starting point or origin, which is 0, there is no value for the random variable beyond this point, and there is no value beyond this point, so the probability at this point is 0, as random variable does not possess any value at beyond the value 0. So it means that there is no negative value for the random variable, so the probability for the values beyond this point will be 0. Now let's suppose random variable can take the value 1, 2, 3, 4, and 5. So random variable can suppose the any value between 0 and 5. We are supposing this, and the probability beyond the point 0 and above the point 5 is 0 for the random variable x. So here we have 0 probability. Similarly with the values beyond the value 0. Y-axis is representing the probability densities. Let us suppose that x is a uniform random variable, so the probability density function will be uniform. So this is the all possible values for the random variable, and there should be some point at which all the values will give the same probability. What should be the point? Let's suppose this is some particular point K, and it should be a straight line as it is a uniform random variable, and we are constructing the probability density function for it, so it should be uniform. Uniform means they should have same behavior. It should be like this. As you can understand this thing, as you have listened the previous part, we have discussed this in part 1, that why this is the one level at which all the probabilities are same, that is uniform probabilities, as this is the uniform probability density function. Now, so this is the uniform probability density function, and these are the probability density for all, or you can say for each unit of this random variable. So now this probability density function is uniform between the value of the random variable, which is 0, and 5. Now, what's the probability between 1 and 2? As you know that this is the probability density function, so total density should be 1, and you have to find out that what is the probability between 1 and 2. So we will change the color of the ink to highlight this. Now, this is the point 1 and this is the point 2. So basically you have to find out the area between these 2 points. Why I'm saying that you have to find the area between these 2 points? Because x is a continuous random variable. It could take any value 1, 1.1, 1.1001, 1.2, 1.3, 1.555. So this is continuous, so it can take the any value. So basically in the continuous distribution functions or probability density functions, basically we are finding out the area between 2 points. That's why we named them probability density functions. We are basically finding out the densities between 2 points or area between 2 points. So we have to find the probability between 1 and 2, which is basically this highlighted area. So this is basically the base and this one is the height. So what's the area? Area is base into height. Base is 1, 2 minus 1 is 1. And what would be the height? Let's suppose this k is 1 by 5. As these are the probabilities and probability should be between 0 and 1. Let me consider that k is equal to 1.1 by 5. So by the definition of area, it should be base into length or base into height, which is 1 into 1 by 5, which will be equal to 1 by 5. So this is basically the probability between 1 and 2, or you can say the area between 1 and 2. Now, what's the probability as it's considered 3 is less than equal to x less than equal to 1/3 of 3. So find out the area between 3 and 3 1/3. So this is 3 and here it could be 1/3. So you have to find out this area. So again by using base into height, base is 1 by 3 into again height is 1 by 5. So this would be equal to 1 over 15. So this is the area between 3 and 3 1/3. Now, consider that 2 point, or you can say that it should be, let me erase this, it should be 1.9. So what's the probability between 1.9 and 1.9 less than equal to x less than equal to 2.1. So this is 2 and 2.1. Let me change the color. Okay. This 2 and 2.1 should be here. So you have to find basically this area. Let's suppose this is 2.1. This point is 2.1. As this is continuous random variable, it could take each and every value in a given range. So the area between 2 and 2.1 should be the difference between 2.1 and 1.9 is 0.2 into height, which is again 1.5. So by simplifying this, you will get 1 by 25. So this is the area between 1.9 and 2.1, or you can say this is the probability between 1.9, or you can say in this way, probability 1.9 less than equal to x less than equal to 2.1, which is 1 by 25. Let me restrict this area more, as I'm going to tight this region more. This could be, let me take this one, probability 1.99 less than equal to x less than equal to 2.01. As I'm restricting it, or I'm tightening the region more, this is 1.99. Let me change the color. Which one? Yellow one. Okay. This is 1.199 and this is 2.01. So this could be something here and here. This would be the more tightened region. So this would be equal to the difference between the 2 points is 0.002, as this is the base, into height, which is 1 by 5, and this could be equal to 1 by 250. So as you are tightening the region, the probability, or you can say the area, becoming narrower. This is decreasing as you are tightening the region. So let me consider one more option. What is the probability 1.999 less than equal to x less than equal to 2.001? So you have to find out the area between these 2 points. Let me erase this as we need the space here. So this should be erased now. Okay, now this one is erased. Now, as we have tightened the region more, so what will be this equal to? It would be, by simplifying this, you will get 1 over 2500. Here I am leaving this up to you how this 1 by 2500 is coming. So 1.99 would be somewhere here, and this should be a very small region. So obviously the area should be very less. So as you are tightening the region, area is decreasing and probability is also decreasing. So what will be probability x is equal to 2? As you have seen that as we the 2 points, as we are finding the area between 2 points, and as they are coming closer and closer, this probability is decreasing as well. So now here we are not considering that area between 2 points, not 1.9992. This is simply at probability x is equal to 2. So this should be simply one straight line, and there should be no base, as the base is difference between the 2 points. Simply the probability at x is equal to 2 is 0. As there is no rectangle here, there should be only a small straight line. So if someone asks you what is the probability at some of absolute point, like probability x is equal to 2, x is equal to 3, or something else, and x is continuous random variable, so what is the probability? Straight away the probability at that particular point is 0. Now let me give some introduction to you. The continuous uniform distribution is a family of probability distributions such that for each member of the family, all intervals of the same length on the distributions of the distribution support are equally probable. As you can see that there is a uniform interval, and a random variable x is uniformly distributed on the interval a and b if its PDF and CDF are, this one is its probability density function, as x is between any 2 points a and b, as we have taken here between 0 and 5. This one is the uniform distribution with two values 0 and 5. So its PDF should be PDF of this particular case should be 1 over 5 minus 0, where x is between 0 and 5. So this is the PDF, and this one is the CDF, cumulative distribution function of the continuous uniform distribution, and this is the mean or expected value, and so you can see from here, this is the height and this one is the base. This is the uniform distribution from A to B. So there is an example. A shuttle train at a busy airport completes a circuit between two terminals every 5 minutes. What is the probability that a passenger will wait more than 3 minutes for a shuttle train? So x is basically the waiting time, and this is f of x should be equal to 1 by 5, as the train at a busy airport completes a circuit between two terminals in every 5 minutes. So they are asking that what is the probability that passenger will wait more than 3 minutes. So as x is the waiting time, and more than 3 minutes means x is greater than equal to 3. So this would be equal to 3 and the upper limit is 5 here, which is 1 by 5 dx, which would be equal to x over 5 this, which would be equal to 2 by 5. So this is the probability that a passenger will wait more than 3 minutes for a shuttle train. So basically this 2 by 5 is this particular area, as this random variable could take the values between 0 and 5. So this particular area is that this is 2 by 5, that the passenger will wait for a shuttle train more than 3 minutes.